Hello students, we are going to study the module corrosion, which is included in your syllabus semester 2. In the first slide itself you can see the contents which we are going to study, that is the definition of corrosion, mechanism of corrosion, which constitutes part 1. In part 2 we have types of corrosion and factors affecting rate of corrosion. The last part includes methods of corrosion control. Now if you see on the right top of the corner of the slide, there are wheels which have been corroded completely. So this is how we are going to begin the chapter, like the wheels which are made up of iron and maybe could some other metals also, like which have got corroded. So why? What are the causes? What are the factors? What are the different types? Who is responsible for this corrosion? So initial part of our chapter will include all this, which we will get the answers for. And if you see in the left side of the at the bottom of the slide, there are chains which have been corroded, as well as in the same peak you can see the coated chains as well. So this includes in the methods of corrosion control. So if any metal is getting corroded, how to prevent corrosion, what are the different control measures to prevent corrosion, all this we are going to study in this module. So to begin with, the definition of corrosion. Now corrosion takes place everywhere, no matter only metals, everywhere. So what is the general definition of corrosion? It is a process of causing deterioration or destruction of any material due to its reaction with the environment. बट देन हम लोग पढ़ रहे हैं मेटल्स. सो मेटल्स रिलेटेड कॉरोजन का डेफिनेशन क्या है? वो एक नेचुरल प्रोसेस है जहाँ पे मेटल्स का स्लो एंड स्टडी या समटाइम्स इन सम मेटल्स फास्ट डिस्ट्रक्शन टेक्स प्लेस. नाउ व्हाई दिस डिस्ट्रक्शन हैपन्स? बिकॉज इट्स रिएक्शन विद द एनवायरनमेंट. नाउ ऑलमोस्ट ऑल द मेटल्स दे आर एक्सपोज टू द environment, be it gold, silver, iron, aluminum, all the metals. So what are the different environmental factors? These are atmosphere, seawater, wet soil, acids, alkalis which we find in the lab, as well as neutral liquids such as rainwater. So how do we define the definition of metals? Definition of corrosion of metals. It is defined as the natural process of disintegration of metals due to its reaction with environment such as atmosphere, seawater, soils, acids, alkalis, neutral liquids, etc. So this is what the definition is expected in the exam. Proceed. Now what is the mechanism of corrosion? Mechanism of corrosion is divided into two categories. There can be a dry corrosion, there can be a wet corrosion. So dry corrosion, or it is also called as chemical corrosion, or it is also called as atmospheric corrosion. The other type of mechanism of corrosion is wet, electrochemical, or immersed corrosion. Now this dry, chemical or atmospheric corrosion occurs due to two reasons. What are these two reasons? Corrosion due to attack of oxygen alone, and corrosion due to other gases such as, I have listed it down. You can see there is carbon dioxide, sulfur dioxide, chlorine, fluorine, or it can be corrosive liquids such as hydrogen sulfide. Generally, all these corrosive liquids, acids, they are stored in steel tanks. So what happens? Steel, we all know, is made up of iron and with few percentages of carbon. So it's bound to, these acids, they are bound to react with the metal present in the steel. So this is what we are going to study in corrosion due to other gases and corrosive liquids. Now when there is attack of oxygen, three different films are formed. What are these films? Stable oxide film. The second one is unstable oxide film, and the third one is volatile oxide film, which we are going to study in detail further. Now let's come to wet, electrochemical or immersed corrosion. Now this type of corrosion occurs due to two reasons. What are these two reasons or two mechanisms? These are evolution of hydrogen and absorption of oxygen. So now in the next further slides we are going to see like हाइड्रोजन इवोल्यूशन कौन से मीडियम में होता है और ऑक्सीजन एब्जॉर्प्शन कौन से मीडियम में होता है. तो बिगिन विद द चैप्टर वी विल फर्स्ट स्टार्ट विद द ड्राई corrosion. Let's proceed. Dry corrosion, as we just now saw in the previous slide, it occurs due to direct attack of atmospheric gases. Direct attack of atmospheric gases such as oxygen, chlorine, hydrogen sulfide, sulfur dioxide. All these gases, they attack the metal surface. तो जब ये गैसेस का मेटल्स के साथ में रिएक्शन होता है तब ये मेटल्स करते क्या है, these metals they form metal oxides. और अगर कोई क्लोराइड है या और कोई हैलोजेंस है then it will form halides. अगर हाइड्रोजन सल्फाइड है then it will form sulfides and so on, carbonates also. So generally we have to remember that this dry corrosion takes place only due to direct attack of these gases. So this attack is due to oxygen and other gases. So first of all we will study attack due to oxygen. So what is the mechanism? So now we know that oxygen is attacking metal, but और वो metal oxide भी form करता है. But how does this chemical reaction, how we are going to explain this chemically? So whenever metal comes in contact with oxygen, it loses its electrons to form metal ions. Let me check with the pointer. I'm using this pointer option so as to just make you understand. Okay, so the metal, when it comes in contact with the metal oxygen, it forms metal ions and electrons are liberated. So metal loses its electrons. As we have studied in the previous module electrochemistry, loss of electrons means what type of reaction? Oxidation reaction. Okay, so these electrons, they are absorbed by oxygen to form oxide ion. This oxide ion reacts with the metal ion to form metal oxide. So in general there is oxidation as well as reduction reaction, which we call it as redox reaction. So we as I just told you, like we studied in electrochemistry, how to remember that loss of electrons is oxidation reaction? Oil rig. Oil rig is what? Oxidation is loss of electrons, reduction is gain of electrons. So this is how you people are going to remember the oxidation and reduction reaction. For example, iron. Fe tends to lose its electrons to form ferrous iron. These two electrons, they are taken up and to react with the metal ion to form ferrous oxide. So in this way the attack of oxygen takes place and oxide, that is metal oxide, is formed. अभी ये जो metal oxide form हुआ है, अगेन इट इज़ डिपेंडिंग ऑन मेटल टू मेटल, मेटल की एफिनिटी क्या है. अब जैसे कि मैं सबको एक ही चीज़ पढ़ा रही हूँ, पर ज़रूरी नहीं कि मैं जितना भी पढ़ा रही हूँ वो सबको इक्वली समझ में आए. इट डिपेंड्स अपॉन योर एफिनिटी ऑफ अंडरस्टैंडिंग. सेम इज़ द केस विथ मेटल्स ऑल्सो. तो डिपेंडिंग ऑन मेटल टू मेटल, ये जो मेटल ऑक्साइड फॉर्म हुआ है, ये जो ऑक्साइड लेयर फॉर्म हुआ है मेटल के ऊपर, इट इज़ ऑफ 3 टाइप्स. कुछ होते हैं जो स्टेबल है. स्टेबल मीन्स इट रिमेन्स फर्मली, दैट वी विल सी फर्दर. So what are the 3 types of oxide film that are formed on the metal surface? And yes, one more important thing, there is the metal oxide which is formed on the metallic surface, that is it takes place either at low temperature or at high temperature, depending on what type of reaction is taking place. So the 3 oxide films are stable oxide film, unstable oxide film and volatile oxide film. All these three films will just see it in detail. Now the first one is stable oxide film. Now stable oxide film, as नाम से ही हमें पता चलता है कि the oxide film which is formed is stable. Stable means the film will remain on the metallic surface, underlying metallic surface बोलिए आप जो भी बोलिए, ठीक है. metallic surface पे जब ये film रहता है, it is nicely held to the metallic surface. But then what happens, it depends further कि ये जो film form हुआ है, stable film form हुआ है, it depends entirely on the metal. So based on that, the stable oxide film is further divided into two types: porous oxide film and non-porous oxide film. What is the meaning of porous oxide film? For example, metals like lithium, that is alkali metals, and alkaline earth metals like lithium, sodium, potassium. You can take iron, you can take calcium, you can take magnesium also. When they react with oxygen, जैसे मैंने आपको बोला था मेटल ऑक्साइड फॉर्म होता है, उसी तरीके से सोडियम ऑक्साइड फॉर्म होता है, कैल्शियम ऑक्साइड फॉर्म होता है, मैग्नीशियम ऑक्साइड फॉर्म होता है. ओके, बट as I told you, it depends upon metal's affinity towards the attack. So what happens, ये जो metal oxide form हुआ है on the metallic surface, ये जो वॉल्यूम है ऑक्साइड फिल्म का इज लेस देन द वॉल्यूम ऑफ द मेटल सरफेस. समझ में आ रहा है? द वॉल्यूम, ये जो ऑक्साइड लेयर फॉर्म हुआ है मेटल सरफेस के ऊपर, ये जो ऑक्साइड लेयर का जो वॉल्यूम है, उसका वॉल्यूम मेटल जो रिएक्टिव मेटल है उसके वॉल्यूम से कम है, जिसकी वजह से क्या होता है, पोर्स आर डेवलप्ड ऑन दिस लेयर. So when these pores are developed, what happens? Pores means voids. ये voids just will allow further access of oxygen to the inner part of the metal. As you can see in the diagram, when the metal surface is exposed to atmospheric oxygen, porous metal oxide is formed. So what happens when pores are developed? Further access to oxygen takes place very easily with the help of these pores. So this underlying pure metals keeps on getting corroded. फ्री एक्सेस मिल जाता है ऑक्सीजन को, ऑक्सीजन और अंदर डिफ्यूज होता है और वो मेटल से रिएक्ट करता है, एंड दिस प्रोसेस कंटिन्यूज until the pure metal is available. Okay, so this is about porous oxide film. Now let's proceed to non-porous oxide film. Now there are few very highly reactive metals like aluminium, chromium, zinc. अटैक तो उन पे भी होगा, पर ये जो अटैक उन पे होता है, जैसे मैंने आपको कहा कि मेटल ऑक्साइड फॉर्म होता है, उसी तरीके से एल्यूमिनियम ऑक्साइड फॉर्म होता है, क्रोमियम ऑक्साइड फॉर्म होता है, जिंक ऑक्साइड फॉर्म होता है. बट ये जो ऑक्साइड फिल्म फॉर्म हुई है मेटल सरफेस सच एज एल्यूमिनियम मेटल के ऊपर, एल्यूमिनियम ऑक्साइड लेयर जो फॉर्म हुआ है, उसका वॉल्यूम काफ़ी बड़ा है मेटल के वॉल्यूम के कंपैरिजन में. सो ड्यू टू दिस व्हाट हैपेंस, ये जो मेटल ऑक्साइड है, ये जो मेटल ऑक्साइड फिल्म है, दैट गेट्स वेरी नाइसली स्टक और adhered, the correct term is adhered to the metal surface. So it gets very nicely stuck or adhered to the metal surface, and it will not allow any further access to oxygen. Obviously जब वो अच्छे से फिक्स है वो मेटल सरफेस पे, तो ऑक्सीजन का फर्दर अटैक इज नॉट पॉसिबल ओनली. ओके, तो इनर सरफेस रिमेन्स प्रोटेक्टेड, दो द आउटर लेयर में जो मेटल ऑक्साइड फॉर्म हुआ है, बट देन corrosion cannot continue. Here the reduction of corrosion takes place, that is the corrosion stops completely. But then if this layer gets disturbed, जैसे कि इसके ऊपर कोई स्ट्रेस आया या कोई क्रैक आया, then this layer is broken down, and then the inner metal gets exposed to oxygen until it is disturbed. corrosion stops. Followed? Okay, you can see in the diagram how the metal surface is exposed, that is aluminium हो, chromium हो या zinc हो, जो ऑक्सीजन पे ऑक्सीजन से अटैक हुआ है, it forms a non porous metal oxide film. So what happens, अगर ये tightly held है, tightly एकदम firm है, तो further attack stops till the oxide film covers the entire metal surface. Okay, so in the exam, the question which is asked is not a direct question like explain stable oxide film, explain both porous and non-porous oxide film. They will simply ask you aluminium oxide film which is formed on aluminium metal can stop the corrosion, explain. So there you have to just remember, okay, मुझे यहाँ पे non porous oxide film को explain करना है. Okay, let's proceed further. The second type of oxide film is unstable oxide film. नाम से ही पता चलता है unstable means there is no stability. No stability means ऑक्साइड फिल्म फॉर्म होती है लेकिन वापस से it gets decomposed back to metal and oxygen. You can see the point number B where I have shown you metal. When it comes across oxygen, it forms metal oxide. But then there are few metals which are very noble, which don't get harmed easily. For example, what are these metals? Obviously gold, silver, platinum. That is one of the reason why we wear ornaments which are made up of gold, silver and platinum, and then we don't wear iron, copper or something like that. Okay, so these metal oxide, these metals like gold oxide or silver oxide or platinum oxide, they are such metals, even though the oxide layer is formed on them, they decompose back to give the metal and oxygen is released back to the atmosphere. Okay, so such films which are formed, we call it as unstable oxide film, which on decomposition gives back metal and oxygen. So in the exam, normally question is asked in university board paper, gold does not get corroded, explain in detail. So there you have to explain, you have to remember, okay, मुझे unstable oxide film के बारे में लिखना है, and diagrams everywhere, diagram is compulsory. Without diagram you cannot even explain this type of topic. So this is about unstable oxide film. Let's proceed to the last oxide film, that is volatile oxide film. You all know what is the meaning of volatile. Okay, so volatile oxide film मतलब जो भी metal होगा, some metals have this tendency कि जहाँ पे metal reacts with the oxygen, oxide film भी form होती है, but then it gets volatilized, then it gets vaporized. Okay, so what are these metals? For example, molybdenum. Molybdenum also forms molybdenum oxide, but then molybdenum oxide is which is formed is a volatile film. So what happens, as soon as the volatile oxide film is formed, the film gets vaporized and once again the metal is left over to get fresh, the fresh metal is just left over to get nicely exposed to further attack of oxygen. So this process continues till the pure metal is available, and let me tell you here the corrosion is very very rapid. So a question might come in the exam like explain the oxide film where the corrosion is very fast and does not stop at all. So there we will write down about the volatile oxide film giving the example of molybdenum oxide. Okay, so this is about the three oxide films formed due to attack of oxygen. Now let's proceed further to attack due to other gases and corrosive liquids. Okay, So what are these other gases? As I told you, it can be carbon dioxide, sulfur dioxide, hydrogen sulfide, chlorine, fluorine. You know, under dry conditions, all these metals get easily exposed to these gases. Especially, where in factories where there are storages and all that, this happens normally over there. Now again, as I told you, it depends upon the affinity of the metal. ज़रूरी नहीं है हर मेटल जो रिएक्ट करेगा वो सेम टाइप ऑफ रिएक्शन देगा, ऐसा ज़रूरी नहीं है. फॉर एग्जाम्पल, इफ़ यू सी द पॉइंट नंबर डी में आई हैव गिवन यू द फर्स्ट टू reactions you see, where silver, when silver is exposed to chlorine, silver is a noble metal, it forms silver chloride. ये जो सिल्वर क्लोराइड फॉर्म हुआ है, ये एक प्रोटेक्टिव नॉन पोरस फिल्म है. दैट मीन्स द अटैक डज नॉट कंटिन्यू. तो सिल्वर क्लोराइड फॉर्म हुआ है बट इट इज़ अ प्रोटेक्टिव नॉन पोरस फिल्म. द सेम क्लोरीन जब वो टिन को रिएक्ट करेगा, इट फॉर्म्स टैनिक क्लोराइड. टैनिक क्लोराइड इज अ वोलेटाइल फिल्म. वोलेटाइल फिल्म मतलब with this tin chloride, which the stannic chloride which is formed will get vaporized, and then after vaporization what will happen, again the tin is once again ready for further exposure towards chlorine, and this process will continue until unless the entire tin metal is finished. So this is what I am trying to explain you in point number B. The degree of corrosion depends upon chemical affinity of metal and the above gases also. Now let's see the next example of a corrosive liquid. ये तो एक गैस का मैंने एग्जाम्पल दिया था, एक corrosive liquid का एक एग्जाम्पल लेते हैं. जैसे फॉर एग्जाम्पल aqueous hydrogen sulfide, H2S. This H2S, when it is stored in a steel tank, let's take an example of a steel tank. We all know steel tank is made up of iron. Okay, so this hydrogen sulfide diffuses into the walls of the steel. That means, if I try to explain you in the form of chemical reaction, you can see the third chemical reaction, Fe plus H2S gives me ferrous sulfide plus atomic hydrogen is formed. ये जो atomic hydrogen form हुआ है, it combines with the other atomic hydrogen to give molecular hydrogen. Molecular hydrogen, when it forms, what happens, it diffuses into the walls of the steel tank. Okay, and it creates pores or voids. ये जो हाइड्रोजन फॉर्म हुआ है, ये चुपचाप नहीं बैठेगा. ये क्या करेगा, उस स्टील टैंक के अंदर जाके उसमें छोटे छोटे खड्डे क्रिएट करेगा, पोर्स क्रिएट करेगा, वॉइड्स क्रिएट करेगा, जिसके वजह से क्या होगा, the steel tank will get slowly and steadily corroded. Okay, जो ये पोर्स फॉर्म होते हैं, जो वॉइड्स फॉर्म होते हैं, उसको हम ब्लिस्टर्स बोलते हैं. इवन इफ़ नॉर्मली भी अगर आप पानी किसी टैंक या पॉट के अंदर स्टोर करते हैं, यू जस्ट टच द इनर लेयर inside wall of that particular tank, it will be little bit greasy. So it's very important that we clean it up time to time. So here also the same thing happens. The molecular hydrogen which is formed will enter into or diffuse into the walls of the steel tank by forming blisters. So in one way, hydrogen is creating corrosion to steel tank. Hydrogen is corroding the steel tank. Such type of corrosion due to hydrogen is called as hydrogen embrittlement. What it is called as? Hydrogen embrittlement. Okay, now if such a steel tank is little bit, the temperature is elevated, or if it is heated little bit, now we all know steel tank 96% of, if iron is present in steel, there is around 0.2 or 0.5% of carbon in it. तो ये जो कार्बन स्टील टैंक के अंदर है, थोड़ा सा भी टेम्परेचर अगर हमने टैंक का रेस किया या फिर हाइड्रोजन सल्फाइड जो हमने हॉट डाला, तो ये जो कार्बन प्रेजेंट है स्टील के अंदर, इट विल नॉट रिमेन क्वाइट. दिस कार्बन विल रिएक्ट विद द डिफ्यूज्ड हाइड्रोजन टू फॉर्म CH4, and then this is how, slowly and steadily the composition of steel will get disturbed, the entire composition will get disturbed, and this is how the steel tank will get corroded. Such type of corrosion which takes place due to carbon by reacting with hydrogen is called as intergranular corrosion. This we are going to see in different types of corrosion further, but then this is what I wanted to show you, how a corrosive liquid such as hydrogen sulfide, you know it spoils or deteriorates the composition of the tank by forming hydrogen diffuses into the tank to form blisters, which we call it as hydrogen embrittlement. Then hydrogen embrittlement doesn't stop here. Carbon which is present in the steel reacts with hydrogen to form intergranular corrosion. So this is how corrosion takes place due to other gases and corrosive liquids. So this is all about dry corrosion or chemical corrosion or atmospheric corrosion. Thank you.